Okay, the one thing I forgot to dig out, which I will have to dig out tomorrow, is my three-dimensional display that kind of talks, we can look at, well, wait, do I still have it? Ooh, I may be lying. I may not still have that display, but I can pull up one online. That's what I'll do. Conic section display that kind of shows you how the parabola, the ellipse is today's topic, and then hyperbola, which is yet to come, how they relate and where they come from. Okay, so for today, we're just going to go with the shape, which when I think ellipse, I don't know about you guys, but that picture makes me think oval. Yes?
Yeah, but it's not flat.
What do you mean?
You just said a three-dimensional.
Well, these shapes are two-dimensional. They come as a cutout from a three-dimensional shape because they come from cutting out a piece of a cone.
Gotcha.
Okay. So, yeah. And as I said, I have some really good graphics I can show. I just totally spaced on getting brought up this morning. It was on my mental to-do list, and then I forgot. So, but as you look, okay, so essentially, ellipse looks like a oval, right? And that is, the gist of it. By definition, an ellipse is the set of all points in a plane whose distances from two fixed points have a constant sum. Okay, so those two fixed points that we're going to talk about, the fixed points are called the foci. In other words, instead of having one focus, a parabola had one focus, an ellipse has two focuses, but we don't say focuses, we say foci for plural. Okay, so foci being the plural of focus. Got to get the English grammar in here too. But the idea, so this ellipse, this oval, any place on this oval or on this ellipse, the sum, how does it read? The distance from the two fixed points have a constant sum. So focus and focus, yes? So this right here, that distance and that distance is the same sum as, say, this point over here. It's this distance and this distance. Same if I pick a point over here. The distance from this foci and this foci, they add to be the same number. Okay, so that's the idea of how an ellipse is formed. Now, I'll grab out my cone tomorrow or my 3D image on the computer, and I'll show you. But an ellipse is basically like a slanted cross-section of a cone. Okay, that's the idea of where an ellipse comes from. A parabola is a vertical cross-section of a cone. An ellipse is a slanted. I'll talk more about that tomorrow. Okay, so we have an ellipse, foci. There's 2 points inside the parabola, or inside the ellipse. The line through the foci is called the focal axis. So the distance from one foci to the other foci, or one focus to the other focus, is the focal axis. The point halfway through the focal axis is called the center. So just like a circle has a center, an ellipse has a center. The point where the ellipse intersects its axes are called the vertex, or vertices. So instead of having one vertex, we have two vertexes, or in other words, a pair of vertices. So here's our center of the ellipse. Foci are a little farther out, and then we have the vertices, which are out here. Okay? The longest line going midway through the ellipse, passing through the foci, is called the major axis. So the major axis is, first of all, the longer axis. It has your foci on it. It has your vertices at the end of it. The opposite of the major axis is the minor axis. And that's the shorter line going midway through the center. So like right here, this ellipse is more horizontal, what I would call a horizontal ellipse. The longer line is this horizontal line, so that's my major axis. The line that goes perpendicular through it is my minor axis. The minor axis does not have vertices. It does not have foci. It just meets the major axis at a right angle, and it's always shorter.
Will the horizontal axis always be the major axis?
No.
Okay. That's just the example that we have. Okay.
what this picture is doing right here is this picture is giving you all of your vocabulary. Okay, this is ellipse happens to be drawn as a horizontal ellipse, and it's giving you all of your vocabulary. So if you forget, okay, where's a foci? Where's a vertice? What's the center? You can go back and look here. Okay? Now, when I say that come test time, I'm going to give you a whole page of notes. Ellipse, first of all, I'm going to give you all this information right here. I'm going to copy this straight from the notes, and this will be a part of your notes in the ellipse. And then I'm going to give you this chart we're getting ready to talk about. And then there's a second chart on the back I'm going to give you. Okay, so as I said, I'm giving you lots of information. Thus, it will be a whole page of ellipse notes. And I will make sure, I always just hand out paper copies in class. I will make sure to get that on PDF for anyone virtual that will need to print it. I won't worry about handing it out till we're talking like closer to test review. So, now on the front side of the notes here, and what we're going to talk about today is we are specifically talking about ellipses that are centered at 0, 0. Eventually, when we flip to the back side, we'll talk about ellipses that are centered at HK. In other words, ellipses that move left, right, up, down. But right now, trying to keep it easy, just talking about ellipses with a center of 0, 0. Okay? As you look at these ellipses, notice we have a left column and a right column. Just like parabolas, we have two columns of information. On those, it was, okay, the first column was the parabola opening up or down. The second column was the parabola opening left or right. With an ellipse, what do you notice? Yeah, which way is the longer axis? Yeah. Okay, so the first column is what I call at a horizontal ellipse because the longer axis is horizontal. The second column, the ellipse is standing on its end, and it's more of a what I would call a vertical ellipse. The major axis is vertical. Okay? Got a new standard equation for you. X squared over a squared plus y squared over b squared equals 1. Or, notice the difference over here. Y squared over a squared equals x squared over b squared equals 1. I think I said equals instead of plus there. You guys all have it written in front of you, assuming you have your notes. Yeah. Yeah. The big difference is here, the variable. So in this first ellipse, the major axis is horizontal, which means the major axis is the x-axis. So x squared is over a squared. Over here, my major axis is my y-axis, and so y squared is over a squared. Mm-hmm. Yep. So focal axis, x-axis or y-axis, foci, okay, plus or minus c, comma 0. And so you'll notice it's plus or minus c, comma 0, because it's left c, and we'll talk about what c is, and it's right c. Vertices are plus or minus a, comma 0, so left a and right a. And again, this is because this is centered at the origin, right? The major axis is 2 times a, because if you go right a and left a, that's 2a. The minor axis is 2b, because the endpoints of the minor axis are up b and down b. And then we have something called a Pythagorean relationship. Note, it is not the Pythagorean theorem, is it? It's very similar to the Pythagorean theorem, but it's not identical. So the Pythagorean relationship for an ellipse is c squared equals a squared minus b squared. And this is what relates a, b, and c, and what we'll use when we need to find a, b, or c possibly. Okay? Depending on what scenario you're given. Yes?
Now, would it be the same though if it was a squared minus b squared equals c squared?
Yeah, you could say a squared minus b squared equals c squared. Okay. Over here in the second column, notice my foci, instead of being the c and then 0, it's 0 then c. Vertices are 0 then a's. Major and minor axis and Pythagorean relationship are all the same. Okay. let's look at a couple of examples and see what we can figure out today. What is this class? We're 14 after. My hope is to get through example 1 and 2. We'll see. I don't know if I can make it today or not. Okay. Find the vertices and the foci of the ellipse 4x squared plus 9y squared equals 36.
So we have ABC, right?
We do not have ABC. We need to find ABC because if you look, when it says find the vertices and the foci, well, vertices and foci means I have to know A and C. And the big thing we have to look at, okay, look at your standard equations. Whether you look at the first column or the second column, because we don't really know which one this is right now. Am I in standard form? Am I in the form of a standard equation? No, because a standard equation has to equal what? 1. You're not in the form of an ellipse if your equation does not equal 1. How do I make this equation equal 1? Okay. I would say.
I'm going to say multiply everything by 1.
Okay, so I'm going to go the route of divide by 36. Okay, and going with, not that we couldn't subtract by 35, not that I couldn't divide by or multiply by 1 over 36, but I'm going to go with, okay, how do I divide to make this 1? And so I'm going to divide by 36. If I divide the right by 36, we're dividing everybody by 36, yes? I'm going to zoom in here so you can see what I'm doing. Okay, what does this look like? What does this simplify to? So if I have 4x squared over 36, what do you know about 4 over 36? It's 1/9, yes? So add in an x squared and think of this as x squared over 9. I just don't need to write the 1. Plus, what do you know about 9 over 36? Reduces to 1/4. And so if this is 1y squared over 4, I can write it as y squared over 4 equals 1. Okay. Now, are we looking more like standard form? Yes. Now, I'm going to slightly tweak how we write this in that if you look up at standard form, and I'm not going to scoot it, you all have it in front of you. It's x squared over a squared and y squared over b squared. What is 9 if I write it as a square? 3 squared. So I'm going to rewrite this as x squared over 3 squared plus y squared over, what do you know about 4?
2 squared.
2 squared equals 1. My reasoning for doing that, what did we just find? A and B. Now, the question does become, how do I know whether X or Y should go first? And what I will say, in an ellipse, A is always your bigger value. A is always bigger than B. So in this case, if one of my values is 3 and one of my values is 2, the bigger one has to be A, and so that tells me that A is 3. And in this case, B is 2. What do you mean? They cannot be the same number. If they are both the same number, it's no longer an ellipse, it's a circle. Okay. So, based on the fact that A is 3, A is my bigger number, and A is under which variable? X. Which column am I using to write this? This is a left column problem. Do we understand that? Because A is bigger and X is over the bigger, over the bigger number. So this is a left column problem, or first column if you prefer. And so that means this is in the form x squared over a squared plus y squared over b squared equals 1. Now, the question becomes, backtrack, what were we asked to find?
Foci and vertices.
Okay, vertices and foci. According to our chart up above, what does it say about vertices?
Plus minus A and 0.
Okay, right there, left column. Vertices, plus or minus A, comma 0. What does it say about foci? Plus or minus C, comma 0. My point there, I'm not doing anything fancy to find those formulas, right? They are right there in the chart. I just went up to the chart and I found them. Foci, vertices. Okay. Well, what can you tell me about the vertices?
We know A, so we just need to put it in.
A is 3. And if my vertices are plus or minus A, comma 0, that means my vertices are... Okay. 3, 0, and negative 3, 0 are where my vertices would be. And yes, for these purposes, you can write it at plus or minus 3, comma 0. Okay, halfway there. What about foci? We need to find C. We don't have C. We have A.
We have A and B, so we can use it.
Okay, so we have A, we have B, we have something called a Pythagorean relationship. And it doesn't matter which column you look at. The Pythagorean relationship is C squared equals A squared minus B squared. And it will always be that for an ellipse. So if you haven't already done the math, do the math. C squared equals 3 squared minus 2 squared. 3 squared is 9, minus 2 squared is 4, 9 minus 4 is 5. Is this taking you guys back to Pythagorean theorem type days? You know what to do. If C squared is 5, what's that mean? C is plus or minus the square root of 5. In all reality, actually, C is just the positive value. In this case, when we talk about A, B, and C, it's just the positive value. So square root of 5, yeah. Because, now, if we need plus or minus, what's already in the formula up here? The plus or minus is in the formula. So, kind of like Pythagorean theorem. When you actually do the Pythagorean theorem, do you actually put plus or minus in an answer? And you don't. If C squared is 5, then you take the square root to get C. So C is square root of 5. If my foci are plus or minus C, comma 0, my foci are plus or minus square root of 5, comma 0.
So then, C doesn't always have to, or whatever C equals is always going to be under a radical, right?
No, C would not have to necessarily be under a radical. Right. Okay, guys, you can start looking at the homework a little bit, but honestly, I didn't get very far, did I? So, the homework is in Skyward if you want to get it. If you can't get it off my board, let me know if you have questions. We will continue ellipses tomorrow.
I would have done one of your comments.